Hello everyone. So today we have Codeforces Round 795. It is an Indian round. Let's see how it goes. In the sequence A1 to AN, find the minimum number of elements to remove from the sequence such that after the removal, the sum of every two consecutive elements is 0. So basically all the numbers have to be either even or odd. Right. N minus N minus 1. Hopefully this shoe shuffling. Class of students got bored hearing the same word. There are n students in the class and you are given an array S in non-decreasing order. Okay. Where Si is the shoe size of the ith student, a shuffling of shoes is valid only if no student gets their own shoes. And if every student gets shoes of size greater than or equal to their size. Greater than or equal to. You have to output a permutation P of 1 to n denoting a valid shuffling of shoes, where the ith student gets the shoes of the pith student. Permutation P denoting a valid shuffling. Okay. So basically, if I'm like here talking about 3, then the next greater element should come here, which is 6. But then, what about 21? Okay, so I think it is like if there are two values which are equal to the maximum of the array, two or more values, then I think it is good, otherwise not. Or so is it like minimum has to be equal to the maximum? Because otherwise I don't think there will be a valid combination. And in that case, I mean, we can print out anything. So if minimum is not equal to the maximum, then I think there is a problem. Yeah, there was this condition. So I think for that what I can do here is set modulo n+1. I think this should work, but for only, yeah, what if there is only one student? Ith student gets the shoes of the pith student, where pi is not equals to I. So for like this permutation, for the first student will get the shoes of the E1, so it is also 1. Wait, what? I mean, we can print out like this at least. So it would be, I think, n minus I. And so I can also do it like this. If I 0, let's see out and see out n minus I minus 1 times 1 minus. No, not minus 1. Yes, still don't get this question. Maybe what I'm doing is further. Okay, let's see. Don't know what this question actually requires. Let's see problem C and D. Sum of substrings. You know binary string as of length 1. Let's define di as a number whose decimal representation is. Here we define fs to be the sum of all the valid di. Okay. In other words, fs is for example, for the string d1, okay, in an operation you can swap any two adjacent elements of the string, find the minimum value of fs that can be achieved if at most k operations are allowed. So one thing that I might do is you can have a priority queue, right? So if I swap like these two digits, then it will affect three, yeah, in total 3 numbers. Okay. So at the time of pushing it into the priority queue, I think what I will do is I will push a tuple of pair of int. But but I think that will not work. Maybe TP is equal. Oh, the value of k can be up to 10 to the power 9. And you are given a string and array as non-decreasing order as a shoe size. Shuffling of shoes is valid only if no student gets their own shoes, and if every student gets shoes size greater than or equal to this. You have to output a permutation denoting a valid shuffling of shoes. So what are the negative one cases? I mean, I think this is a minus one case only because the minimum is not equal to the maximum. I think for n equals to 1, I need to print out negative. Instead, the one that yesterday I was missing. I mean, that's dumb. Also, since this is like the array is sorted in non-decreasing order, so we can just check it like this. So if n is 1, then C out minus 1. Else do it like this. This is what I'm missing. Really? So, still. So am I the only one who is having this incorrect approach, or some other people also? Wait, what? Submitted 4 problems. They also were running, but on test case 3, we got it correct. We also got that correct. We also got on test case 2. Test 2. Okay. So I mean for n equals to 1, it has to be equal to -1, right? And for n equals to 2, because the person with the smallest shoe size, the shoes of that person is not usable, right? Like how will the student with the largest shoe size will use the shoes of the guy who's having? Oh, ah. So if there are like so if there are more than one shoes of same size, then I think I have an answer, otherwise no. Oh, but then that circularly person in the shoes, right? Okay, and m of vi minus if m of vi is 0, then I think what I need to do is see out some of previous variable which is initially pointing to 1 and see out that else see out I, and in that case set p equals to I plus 1 and it should be I plus 2. So 2, 3, 4, 5 and minus 1. Right? Yeah, I think so. Two, two, three, 4, 5. Oh, not 2. Which one has more cells now? C. C has more cells. So since this value is so large, let's as well have a look at B. Given an array A of n integers, asked to find out if the inequality maximum of ai to aj is greater than or equals to ai plus aj. Okay. Holds for all pairs of indices. The maximum is more than the sum. Oh, some negative values are also. And I can be put with this. So any contiguous subarray which has more than one positive numbers will cause us problems, right? Simple adding something. So in the second case, what I will do is -1, then 2, okay, but then -3 and 2, okay, then this 2, no problem till here, then -1. I think this is easier than the C problem. Just feel like today my feeling has been off by a while. Right. And maybe I can solve the problem in this loop itself. Right? But like in this case, won't the answer become -1? And in this case, so this is an easy question. Yeah, in this case has no problem at all. And yeah, this should not be greater than or equals to vi. Maybe it should just be greater than or equal to 0. Right? Equal to 1 minus. So now if temp is equal max, then everything is fine. Else, that is false. So see out F, then yes, else no. Right. And yeah, in this case, set time equals to 1. And actually, if temp is less than 0, then set temp equals 0 and m is also equal 0. Right. No, and no. Oh, not only equal, greater than equal. Maximum should be. Am I missing something? Yes, so let's say we have -3, then 1, 2, 3. Should we know? Let's say -1, still no. Let's say 1, still no. Let's say 0, no. Let's say 2 and -1. This one is interesting, but it should be. I think it is good. Let's see. Wrong answer on test case 7. In this case, should equal to be included or not? So the thing is, let's say I was having 1e9, so minus 1e9, then 1e9. So it is equal to 0, right? But now if I am adding 1, then 2, then I don't know, maybe actually, so if we are adding like two positive numbers, then itself it is 0. Oh, no. Like when I'm adding this 1, so for this moment, the maximum is greater than the sum, right? So yeah, it will always be like that. I think so. And I'm having everything as long now, so there won't be any runtime here. Mx is equals to maximum of mx. Can set it equal to 0, but I don't think it as time equals to VR. Ah, but no. I'm still not sure about the 0 case. Mx equals to VR. Let this convert. Oh, no. Mx equals to VR. I think it doesn't be 10 plus 10. Okay, let's try some more examples of some leveling. No, sure. Still no. Now yes. Now no. Now also no. Oh, yeah, now yes. No. No. Still no. Oh yes. No. Then what am I missing? Now it should be no. In the zero case, no matter what, maximum will become greater than or equal to the time. Oh, maybe this is two, no, minus one, then two, then -1, and then I don't know which one, right? So total numbers are like, it is saying yes, but it should have been no, right? Because 2 plus 3. So I have one more condition. That if the sum is less than max, then max equals to sum. Basically, max equals to minimum of maximum of time. But now I don't know even the samples. Samples of, okay. MX, because in that case the sum was important. Like even if I had removed 4 from 5, there was still one remaining. That one was crucial, I think. Yeah. So I think it will not work like this. No, no. Another terrible now. Oh, go on something. Oh, so only a binary issue. Oh, so the values. Oh, string is binary, but you have to consider it as decimal digits. So the only possible values are, yeah, these and the 0. 0, 1, 10, and 11. How many substrings do you I think that was the only base which I was missing. But here the problem is, like, -1 will be set right here. I mean, the value of flag which is right there. Yeah, I can simplify. It's good that it is considering this case also as -1, but it failed there itself. So should have one more max variable, max2. So will that denote the next maximum value? So will the third maximum value also be required? Second maximum is required. Oh, what should it be like if temp is less than or equals to v of I, then mx should be set as vi. If temp is less than or equals to vi, so in that case, no, it was still 3. Temp minus vi, But maybe that's maybe to mx equals to else set temp equals to vi and mx equals yeah, I think this is where this has to work, and this is also right. I think the only thing is this. So if the temp is 1, then I am adding another one, then it will become 2, and then if I add anything, like if I increment its value by 1, no, that's wrong. I increase its value by 2, and also it is wrong. Yeah, maybe this is something. Yeah, let's see. Please no WA on second pages. Yes. Somebody said 3. Yes. Should I test it like that? It's a very bad way to do this problem, but okay. What 6? Let's see. And so mod 10, let's say -5 or minus 9. Now f1 equals to solve, let's say main 1, and f2 equals to main 2. Right. And here debug f1 and debug f2. int no 0. Yeah. Yeah. Test right. Some issue will be here, I think. Let's just run it in. I got main one and main 2. Mod 171. We don't know where am I. Line 75. Oh, minus 1 to 1. Problem is with this one. No, working correctly. Wait, what? Why? So it is 1 at 6. Then minus 1 it became 0. But yeah, still. Wait, what? Wrong answer for this case. Zero, 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 zero. 6, comma 6. Then 2, comma 6. Sum is 2 and maximum is 6. Okay. Then I added 1. But maximum. So basically, if VR is positive, then maximum should be equals to VR. Right? Or let's see the video maximum VR. 3, comma 1. Then now where do I? 9 comma 9, then 6 comma 9, 8 comma 2. Oh. Ah. Basically, Vi is less than 0, then we will never have any problem. Is this what they are trying to say? Like we should check only if this is the case. Maybe. I said no, but the output was yes. We don't. I mean, it should be yes, no, then my output is 0. Ah. What? Oh, because I didn't. Wait, what? What is happening? Oh. It should be no, right? Or no. Ah. 10, 10, 7, 10, 9, 2. Okay. But 10, 7, 2. Then that maximum minus negative. Mm. My current maximum is 2. Minus 87. Minus 93. But then what? Seven two, but then that plus 10 is probably going to. So at each index, like if I am here, I want a prefix of it, any prefix of it, which is having a positive sum, right? Basically the first prefix or the first suffix starting from this index, which is having a positive sum. And the maximum value of that suffix. Finding out that finding out maximum is easy, but how to find out the positive sum? The first index where the sum gets positive. So for that, if there is like a positive number adjacent to it, then it is easy, but otherwise the first prefix where the sum of some numbers is the sum of this part plus this part. So a sub-array which has the maximum positive sum. Let me explain. sum of this part should be positive, right? Maybe I'm thinking too complicated. Something to do with this itself. So if I add -3 to 10, I get 7. Now if I am getting like 4, any difference of 4, that is problematic, but I'm getting a difference of 3, which is fine. Nine is greater than 0. Or maybe a stack. Which will have numbers like this. So initially I will push 10 into the stack and value of 10 becomes 10. Then when I'm having -3, then let's say I'm just pushing it into the stack. Value of temp is 7 now. Then 2, 9, -2, 7, then 3 and 10. Okay. Okay. The only reason why I think a stat should be used is stat I'm having a -2 just after a 2. Oh, so whenever I am having a positive number, then I should just push it into the stack, something like that. Okay, let's just move down. So if v of I so if v of I is positive, temp plus v of I is more than 0, then temp plus equals to v of I if v of I is positive, if stack is not empty, then stack dot push back, push or push back, no, maybe just push only vi, and also set max equals to maximum of mx comma v of I. If mx is less than temp, then f equals to false right away. If vi is more than 0, vi is positive, then do push it inside the stack. Okay, so that is correct. That is correct. But if stack is not empty, that's good. But if v of I plus stack dot top is greater than maximum of vi comma stack dot top, then there's a problem, right? Stack dot push vi. So yeah, if the number is positive, then there is literally no problem. I mean, the answer will be false right away. Don't need to think there. Stack is not, if stack is empty, then I mean we don't have any option. Just push it into the stack. If vi is negative, yeah, then there is a problem. First of all, while vi is not empty, while stack is not empty, and stack dot top is less than v of I, right? So stack dot top or stack vi minus equals to stack dot top, or the problem is if it is negative, so yeah, if it is negative, then I will have to add it into vi, right? So if v of I, if stack dot top is less than 0, then stack dot, then we have plus equals to stack dot top, right? If it is greater than 0, then do stack or vi minus equals to stack dot top. No. So vi is negative here, so I should add it. So I am adding it in both cases now. If it is negative, then also add. If it is positive, then also just add it. And after that, something like, and also hashtag dot pop that, and I think I don't know for pop it just one. Right now, if stack dot top is 0, or if vi is not 0, if vi is more than 0, then stack dot push vi, right? If vi is greater than 0, will vi ever be greater than 0? No. No. Or Oh, so if your stack is not empty, it should be like this. Then stack dot top, or maybe entity stack dot top minus v of y stack dot pop stack entity is right. And in the cells, just set time equals to vi, maximum equals to vi. And yeah, if vi is greater than 0, and also do step dot push vi. Maximum of 0, 0. No, this should work. I mean, if this doesn't work, then it would know where the problem is. So let me leave up something. Can't create over the stuff. Should I just use a vector then? Or should we replace it with thinking top replaced with back? Back. Then even just do this stuff. Ten 13 with about why? Stack is not empty. Inside top equals to stack dot top minus vi. It was 10. Oh, so 10 minus. And 7. And then I got a 2. Yeah, that's perfect. That's also good. I got a 3. At this point, I'm saying, why though? Oh, because 7 plus 2 is 9. That's not. Then a pair of anything. X2. Where? Mm, now no for this case. I got a -3. So vi is greater than 0. No, for -3. Okay. This minus, it is 1. 1 is not less than that. So positive number plus vi is less than 0. Then there is a problem. Positive number plus vi. It is 1, 1 minus 3 is -2, right? Then why it did not come? No. Oh, okay. Oh, I said true. No, I did not say that. Yeah. Okay, let's take it. Yes. Okay. Now let's try to solve C. Yeah, C has many. But like here, for 10, for k equals to 10 to the power 9, I'm not sure how will I solve this. Everyone's getting this. So if I sort it, but that's just bad, right? So for the second test case, I don't think there is any need to swap the values. Yeah, I don't think there is any need. Oh, there is. But I think the answer will be same in both cases, right? 1, then 10, then 1, then 10, we are 22. Okay, so basically 0, 1, 0, 1, 0 is equivalent to 0, 1, 1, 0, something like that. So in the first test case, doesn't matter, or it does matter? Yeah, it does matter. So if I had like 3 options, like the value of k was 3 or more than 3, then I could have converted it into 0, 0, 1, 1. Yeah, in one step it would become 0, 1, 1, 0, then 0, 1, 0, 1, then 0, 0, 1, 1. Yeah, and that will have the minimum value as 12. And currently it is equal to 21. Oh, so we need to output the sum, the minimum sum, and not the final string. So like in the third case, in the third case, 0, 0, 1, 1, 0, and I have 2 options. So the ideal case would be to put all the ones at the end. It would become like this. Oh, so what if 0, 1, 0, 1, 0, 1, 0? In this case, the answer is 1, and 1, and 1, and which is 33. Okay, so and if we are having 0, 1, 1, 0, 0, then it would be 1, 11, 11, and 10, which is again 33. So it will not change much. So similarly, it is like this 0, 1, 0, 1, 0, and 0, 1, 1, 0, 0. Then also it will be same, right? 1, 10, 1, 10, 22, and 1, 11, and 10, yeah, 22. And so the only place where it will change is when all the ones are adjacent and are at the back of the string, right? First of all, ones have to be at the back of the string. Am I correct? Otherwise, there is no point of swapping. Like you will not get anything by swapping. Basic equals to n. So if k is greater than or equals to, let's have a final string as well, or let's have a final vector of int and of, or maybe just we can swap inside the string. So first of all, if Si is equal to 1, okay, now if back minus I is less than or equals to k, then swap S of I and S of back, right? And k minus equals to back minus I. I think this is the way to do. And also do back minus minus. Yeah, I think this is correct. Then at the end, for int I equals 1, I less than n, I plus answer plus equals to S of I minus 1 minus 0 into 10 plus S of I minus 0. And see out answer. I think long was not required, but just for safety. So I think this will work. WM second test. Swap SI and S of back if the number of operations. Is there some other condition also? Oh, so we can send them to the other end as well. Yeah. So if I send them to the other end, how will that, how to count those values? So let's call it back 2 and let's have back 1 equals to 0, and maybe have one more variable as this. I should be less than or less than j. I minus minus and j plus plus. Okay. So yeah, now do this and this. Yeah, this is right. Create two vectors v1 and v2, both of size n, right? and yeah, the value should be initially equals to, let's say 1e, or let's say n, right? So now if it is not the case, then just s of I equals to, not s of I, v2 of I equals to 0, and don't swap these. Instead, v2 of I should be equals to back minus I, right? Yeah. Yeah. I equals 0, I less than 1 and I plus plus. Yeah, now k equals to, let's say k1, and back equals to 0. And here I should do back plus plus, and here it should be I minus 1. But what 4 operations are required? I know. Why is k becomes 0? K is 0. Why? How? What's the value of I? Oh, but then why these values are updated? Value of k is, oh, yeah, now it is right. And now for int I equals to, okay, for int I equals to 0, I less than 1, I plus plus, if v of I plus if sum plus v1 of I is less than equals to k, then sum plus equals to v1 of I, right? And J1 equals to this one. Right. Maybe this -1. And now, so instead of this, I think I should have counted. So here I should do count plus this. And also, like, I need to store this value somehow. So J1 equals to 1. Now for int I equals to n minus 1 I greater than equal 0 I minus if v2 of I so like I should put one of the values to one of the ends. This is clear. Should definitely do that. I don't know, maybe just no. No, this won't work. Yeah, this also. I think this was an easy problem, but I messed up somehow. Huge negative from the. But yeah, this was it. This and I think I should explain the problems also. Beat dots. This problem I think is quite easy and most of you would have solved this. So like we are given a sequence and the minimum number of elements to remove from the sequence such that after the removal the sum of every two consecutive elements is even. So yeah, if we are summing up two numbers, then like only four cases are there, either both are odd and one odd, one even, both are even, and first one is odd, first one is even, and second one is odd. So in this case, the sum will be even, right? In this case, the sum will be odd, even, and odd. So yeah, just for, if you just keep in mind these things, then you can easily solve this problem. So in the final sequence, all the elements have to be either either like even or either odd. So if it is in this sequence, for example, all the elements are odd, so yeah, it is a perfect sequence or whatever name to give. So yeah, or like here four numbers are even and one is odd. That's why we are outputting one, that if we somehow change this 3 to a positive, to an even number, then we will have a perfect sequence. Good. Then problem B, shuffling a class of students. Okay. So here the one thing that you need to realize is that let's have both these examples. So in this case, okay, I will explain it later. So like first we need to understand that what's the problem with this case. The problem with this case is that the person who's having shoe of size 3 can get a shoe of size 6. This one can get 8, 13, then 15, then 21. But what size of shoe will this guy get? So like 3, we cannot give a shoe of size 3 to this one. So that's the reason. That's one of the things. Now let's say we had something like 13, 15, 21 and 21. So in this case what will happen? Same thing. 3, 6, 8, 13, 15, 21, and like 3 we cannot assign, so -1. So one thing you can see that the guy who is having shoe of size 21 can get a shoe of size 21 again, but not a size which is less than its current shoe size. So who can get this shoe? This is the main thing. Who will get the shoe of size 3? So the person who is already having a shoe of size 3 can only get this shoe, right? Because yeah, the greater than or equal to shoe size. That's why every size, every size which is given us in the sequence should be like occurring or should be present more than once. So in this case, like 3 is present only once, so we cannot assign. 6 is present, so like since 3 is present only once, we will not check for others. But if we are having like something like 8, 8, 13, 13, 15, 15, and let's say 21 is present only once, then also you can check out what's the issue here. So this guy can have shoe of second student, this one can have a first one, then 4, then 3, then 6, then 5, then 8, then 7, right? 9, then 10, but it will have to wear the shoes of itself, so that is not allowed since pi cannot be equals to 1. So yeah, that was the case. Initially what I thought that all the shoes have to be of the same size, but then I realized that if there is only one student who is having, like there's only one shoe is given, then pi has to be equal to y. This is also a case, like, and the value of n can be 1. So if like there's only one student of which is having shoe of size 5, then there's a problem. And then I realized this duplicate or like more than one shoes of same size should be there. That was problem B. Then, well, problem C, I couldn't solve it in the contest. Maybe I should work on my implementation skills, and as well as I should practice more constructive algorithm type questions. But this question was also good, not too easy I would say, but it was an easy question if you like give it some time and take pen and paper and like figure out patterns, then you can solve this problem. So what I concluded is that if we are given some strings, first thing we should figure out that how many ones can be present at any of the ends. So basically what we want to do is to push or to put all these ones to one of the ends of these strings. Why we are doing so? Because let's say we have something like this, okay, then the answer would be like the sum would be this 22. But instead if we had something like this, then the sum would be 1 plus 11, which is just 12. So you can see that if we are having ones to any of the ends, but and yeah, one more thing, you might think that why not just put them together and in the middle of the string somewhere, so that will not help us. It will still be 22. So yeah, we should have those to the ends, and then I think just implementation skills come to the picture. And yeah, you are given k moves and you need to figure out how many ones you can put to any of the ends of the strings. Construct that string, then figure out the answer, and yeah. Then this problem, this one, I don't know if it is good, bad, or what. So you are given an array A of n integers. You are asked to find out if the inequality maximum of this holds for all pairs of indices I, j. So if you saw the screencast, then you will have seen that how I debugged this problem, figured out many corner cases. So these are few of the corner cases. Like if you are also solving this problem and stuck at it, you might have a look at these cases, and this will help you understand this problem better, or I don't know, maybe you can debug just by looking at this problem, looking at these cases. So like in this case, the answer will be yes, and in this case also the answer will be yes, right? And in this case in this case also the answer will be yes, and in this case also the answer will be no, right? Or no, yes, it will be yes. And in this case also the answer will be yes. So I basically maintained a stack. I messed up something. Like I couldn't recall that what were the functions called for a stack, so I used a vector. And maybe when I was debugging also, then it helped me to use a vector instead of a stack. So yeah, you can use a stack as well. And the primary purpose, I think, for this problem, like the main solution that the author wanted us to code was to use a stack, but yeah, the vector in C++ works as a stack as well. So like for this case, first I will push 1 into the stack, then I will, and yeah, when I push a 1, then with 1 I will also put the, like, I will put a pair of integers, and both the values of that pair will be same. Then when I get a negative number, yeah, this thing is important. The stack will hold only positive values. It will not hold even zeros. It will hold only positive values. And the second value will always be a positive number. We will never push a negative number inside the stack. So when I am having this 3, if I push this 3 into the stack, like I will not push this 3, but what I am currently having inside this stack will be reduced by 3. So if I reduce it by 3, it will become -2, which is not good. So I will just remove this entry from the stack. Now the stack is just empty. Now when I get this 8, still I will not do anything. I get this 4, I will put it into the stack. Then I get -1, so I will reduce this value to, and so the main case when the value will, like when the answer will become -1, is when you are having some number. So let's just take a case like this. So if we put this 2 into the stack, then I'm having a 3. So 3 is also a positive number. So if I just check 3 plus 2, which is 5, and it is greater than the maximum of 3, 2. So in this case, I will output -1. So if the top of the stack, st.top plus dot first plus the current value is greater than the maximum of stack.top dot second, that's why I put it this second. Like if we subtract some value, then this maximum value should not be affected, comma current value. So this is one case, and some other case could be some so let's say we have 7, then -3, -3, 1, another 1, Oh, yeah, if we have a 6 now, then minus 4, I guess, and then a 3. Yeah, I think we should have a look at this case as well. 7 minus 3 minus 3, 6 minus 4 and 3. So first I will put 7 comma 7 into the stack 10 minus 3. So since it is a minus number, I will subtract it from the given value. Then yeah, again minus 3, it will become 1. Then I have a 6, so just put 6 comma 6, and then minus 4, so just subtract it from here. And then 3, so 3 comma 3. So if you look at it like this, then I don't think it will be a problem. Actually, it's not a problem. So what I was thinking about, that maybe some cases like that you add up all the values of the stack and then the maximum. So like the stack is having something like 3 comma 8, then 2 comma, I don't know, maybe 7, and then 9. So if I get a 5 here, for example, then this will not cause us any problem, since 7 is greater than, yeah, the sum is equals to the maximum one. But if we consider this 3 as well, then it will be a problem. But I think what I missed is that, I don't know what I missed. Maybe this is the case or not. I handled this case in the, I felt it was also a corner case. So yeah, we can have a look at the code as well. So yeah, here I am checking that case only, when some prefix of the stack plus the current value is greater than the local maximum. And yeah, this is when vi is positive, so that prefix case will happen only this case. And yeah, this is when I am checking the top value of the stack and the current value of the stack. So where I handled it? Yeah, this is the place where I handled that prefix case. And yeah, this while loop is just reducing the value of the current negative number by adding the positive numbers from the stack. And I am also having this max2 variable, which will just like store the maximum value out of all the popped pairs of the stack. Then when stack is not empty, then if I am having a positive number, oh, if the current number is negative, so yeah, one case when it is equal to 0, that case is not handled there. So for that I will come inside this if condition and check accordingly. And yeah, this condition is also quite important. So if we are having something like, so if inside the stack we have if the current sum value, which is like 10, it becomes less than 0, right, and the current value is greater than 0, then what I should do is that I should remove all the stack, because like if you know about the cadence algorithm, then you know why I am doing this. And if you don't know, then you can have a look at that algorithm. Then stack dot push. Like first I should empty out all the values. The stack will become empty, and then I will push the current value. So this is what I'm doing. So yeah, that like what I want you to understand from the cadence algorithm is that we reset the value of the current sum to 0 whenever we have the value of current sum negative, because like if we are having a negative sum, then better we should not take any element, then we will have a sum of 0, right? So why should we have a sum of negative? We should have a negative sum, right? You will understand once you have a look at the cadence algorithm. I don't know, maybe my D will fail or pass. So yeah, that's it for today. Maybe I will do the next Codeforces round as well, which will be happening on 3rd of June. Yeah, maybe I should do this. Or maybe tomorrow is Code starters round also. Maybe I will give that as well. Yeah, that's it for today. Bye.